All right, so this is all your fault. You just I couldn't stop thinking about this since we went to Tyler's, and thanks for cruising me around. It's pretty cool. But yeah, thanks again for planting this in my ear. So now I'm like, I got to do it. So could I figure out how to lay out a frame, tubular frame with Corel? I'm pretty confident I could now that I kind of scratched this itch. But but I'm forcing, since it's all your fault, I'm forcing you to have to watch this. So you don't have to watch it, but the obvious like 90s. That's great. The proof of concept was B right here. So just doing like a quick front end, like if you're looking at the front here and just based off my memory, what he had, you have your shock tower here. Let's say this is the sway bar axle mount here. And then that's a front view, side view, same thing. So this is kicked out. You have your front down here where the axle, that's C here, and that's C, same distance there. That'd be where the shocks mount. A would be your continuous frame, let's say all the way back. So I'm just thinking this would be the front of something. This is your firewall, purely for just layout purposes. D would be like a vertical here. If you're looking at it from the top, it would be from the side here. So you lay out the front, you lay out the side, and then you take the side and you turn it, and then you extrapolate out, and that helps you build your your front, your side, and your top or bottom, either way. So A would be all the way through contiguous, could be the frame all the way back. And then G and D overlap each other visually, but D is actually kicked out this far, and G goes here, D goes there. So those are like the verticals there. G's are the direct verticals there. And then, like I say, though, B would be the complicated one, because when you're dealing with this two-dimensional stuff, you get the front view of B at the angle that it is this way, but this doesn't tell you how long B is. This shows you the angle forward, but it doesn't show you the length because it kicks in from, so you can't see it here, you can't see it here. And then this third view only gives you how much it kicks out from, coming this way, and then boom, kicks 90 or whatever and kicks over this way. So none of these views will show you that. So that's the problem I wanted to solve, because as long as you could figure out that, then it doesn't matter. This is super simplified. Obviously E might come in at a little bit of an angle as well. D might be kicked back a little bit, to follow B instead of just going straight. Who knows? But again, it's just proof of concept. So I was able to extrapolate that out. It's a matter of just taking this flat. You just got to lay it flat. You take this distance, and then you take the known distance that it has to be from here to here, and then that's that distance there. And that it helps you extrapolate out, and you just do the hypotenuse. You just drill the square, and then that gives you the length of B. So no big deal. So I was able to. So based on every one of these pipes going to the center line of the other pipe, or the tube, whatever the technical term, I'm confident I could come up with a pretty good list to get you to the center. Of course, all these would be ground to fit, but this gets you could cut all this up and be done, label everything, and then work from that. The other part would be then doing the fish mouths, or the coping, as it were. I'm confident that with a little bit of work, I could come up with actually how to lay these out as well for myself. Like I would be confident enough to do that. So you would just, like let's say G or something like that. You would just let's say G, how it copes there. This length would be to the center of the pipe. Sure, you would lay that off, bonk. But then you would have to, grind this smooth, because let's just, for really quick purposes here, you would have this would be the thickness of the pipe itself, of the tube. So that's where you'd have to cut to. So you can see where, unless you sat there and ground this to a point, when you slice this, this is what hits first. Now that's fine, because that's where you actually TIG weld, and you should be able to build that up. I believe that's what he does. If not, you just have to custom hit that. So this would be where, that point there. And then it goes to this point here where you slice it, to there. And this is your fish mouth. So this is where you actually would either run a hole saw, or you theoretically could cut this just straight with a blade. So if you were to, let's just say this G here, we'll just grab these. So you can see this would bonk first. So your fish mouth should theoretically be from here to the center line of the pipe and to there. And then looking at the top of it, that should be your cope, right? So the pipe comes in, bonk, and slides here. The problem is it's going to hit here first. And so unless you chop it here, but then you would have to literally grind this completely smooth to almost, a molecule flush. So the easiest thing to do would be to bring this back. Let's see, I'm going to kick this 90. See, and then you would just bring these in like that. Now that is your actual cope. So when you go to, so now theoretically what you could do is you could slice, wait, hold on. That's not it. It goes to there. There you go. So what you could theoretically do is just slice the tubing with a saw here and then zing it there. And then that way, that's where it'll sit up on the cope. So that way you're here, and then it'll come around to here, and then it'll come back down to there, and there won't be anything here. But again, that's where you can do a nice fillet weld. And then that gives you some strength there rather than trying to sand it to a point. So you'd have to grind for days if you were going to cut it to there. So this would save you on your fish. So if you're looking straight down on this tube, you would just cut it with a saw. And then what this does is this sets us up. So if you were to grab this, and of course the weed whacker guy shows up right now. This would be your actual cut of G. So you could cut G to the length it needs to be. Like that. This would be the actual cut. And then what you would do is just take the saw. So the other thing you do is then take, you'd have your 2-inch pipe here, let's say. And then you would just do a 1-inch square tube. This is just down and dirty. This is how I do it though. And you would lay this on your table, and then you would just take a pen and make a line right at 1 inch for reference. So that way this gives you your midpoint of your tube, right? Because you're just working from the midpoints of all these tubes, because the fish mouths are only going to go halfway and then you're done. You don't have to, none of this is going to wrap around. So what you would do is just make your straight line on your tube all the way across, and then you could mathematically lay this out, no problem. You would just take this in however far and put it in a saw, and using that straight line, that way this would be perpendicular, like perfectly perpendicular to itself. And I'm confident that G would then be cut, fish mouth ready to go, and it should fit right in there. It'll slot right into C and F, and off you go. So that would be the easy way to do all of these. And I this is all 90 degrees, so it should be really just that simple. You would just extrapolate out how much you need to cut back, take that out, and you could cut all your E's to one length, and then go ahead and trim each one, and then fish mouth them properly using your line. Now, something like B, this is where it would get fun, but I'm confident that I could figure it out based on knowing where things are going to touch midpoint. So if you have your midpoint here, it would just be a matter of knowing this is where this is going to touch, and then triangulating to the center line of where it's going to touch here, and then where it's going to touch basically to its midpoint here, or it would be here, and then you would just work that out, literally triangulate, and then work that backwards from from, where this is going to touch, work that backwards to what you would notch on B. But then it would be really important though to set up that baseline here. But you can see where I have nodes. So you would have your 90, and then I have these nodes kicked over at 22 and a half, because just to make things easy, I made this angle 22 and a half, or actually this one here. So I know this is 22 and a half, but essentially I would just set up nodes and you could reference degrees from center. So knowing like this would be your North Star, I would draw, a reference line here, but I would turn it up 90. So that would be like my reference, my North Star. And then working from this end of the pipe, I would just extrapolate where it intersects with C, because it would fish mouth to here. And then, how far it goes up all the way to here. And then I could overlay that onto my knowledge of where it's going to intersect halfway on B. So I know it's going to intersect there. It's going to intersect here, and then it's going to come over to here. And then I could, get that, lay that out. And then knowing, base, like, let's say this would be the 90, the top would be the North Star line. Then how far over, this would be 45 over. So, or 90 degrees. So this would be the top line. And then you go over it, and at 90 degrees over, it's this length. And then you just connect the dot from there. You connect the dot from, from there to there to there to there. Never works out live. There you go. Anyway, so that would be the fish mouth there. So knowing that this would be at 90, and this would be at 12 o'clock, and then this would also be at the other 90, then you extrapolate that out onto this tube here. So you would know that this 90 is here, or that would be 12 o'clock. This point would be here, and then this would be here, and then this would be here. You extrapolate that onto this, essentially. And then you take that information of distances, and then you would lay that out on B. I know this is crazy and you're just like, whatever. But anyway, so knowing that the distance from, you have the North Star start here, and then you would know the distance from there to there. You could extrapolate that down the tube to here, and then you would extrapolate that to over, starting at, this is 12 o'clock, and then where it touches on the, the 90 degree here would be somewhere down here. So then you could make this really complicated fish mouth. So from there to there to there, and then you could just lay it out mathematically, and then, with your grinder, just do surgery on it, but you would know that you're there. Like, so you would be able to just work through, chop all these pieces, and then just take your time. But mathematically it should work, so that way you could sort of get a lot of this done. But, as you start welding, things will change a little bit. So you can build in a little bit of comfort once you get your eye in. But I'm confident that I would trust I would lay this out kind of in real life, sort of lay it out how I want it to look, and then figure out your angles. But I'm pretty confident I could lay out the frame and get a cut list, and I would be pretty confident in knowing my fish mouths are the way to go. So anyway, I just had to scratch this itch. It's your fault. Thanks a lot. So yeah, if you want to get in the buggy business, let me know. I got to get back to work, dude.